Hey everyone, and welcome. As an architect, I get asked one question all the time, just in different forms. And it really boils down to this. How do you secure a fortress that has no walls? Well, that's pretty much what we're all dealing with in this multi-cloud world, right? So today, we're going to break down the blueprint for doing just that, securing your stuff no matter where it lives.
I mean, think about it. I see this constantly. You've got these amazing distributed systems, but the old security playbook, it's been thrown out the window. It just doesn't apply anymore. The whole idea of a secure perimeter is gone, which means we have to start thinking about security in a totally new way.
And that brings us here to what I like to call the multi-cloud maze. You know the drill. You've got workloads running in AWS, maybe some services in Azure, and probably a database or two over in Google Cloud. It's an incredibly powerful way to build, but from a security perspective, whoa, it can be an absolute nightmare.
And here's the problem in a nutshell, right? Each cloud provider has its own way of doing identity, its own security system. Every team might be managing its own secrets. It's like trying to secure a building where you've got a dozen different kinds of locks and everyone has a different set of keys. It's just organized chaos, and it leaves way too many doors unlocked for attackers. So it's pretty clear the old way is broken. We can't just keep trying to build higher walls around our networks and, hope for the best. We need a fundamental shift, a whole new philosophy for how we approach security architecture.
And this slide really says it all. We're moving away from that old castle and moat security model. The one that says hard on the outside, soft and chewy on the inside. Instead, we're moving to a zero trust model. And the philosophy is simple. We go from trust, but verify, to never trust, always verify. In this new world, your identity, not your IP address, becomes the new and really the only true control plane. Let me put it another way. Think of it like this. Even if you work in a super secure building and you have a key card to get in the front door, you still have to use another key to get into your specific office. That's the zero trust mindset. We don't care if you're inside or outside the network. You have to prove who you are every single time you try to access anything. Okay, so this is where it gets really good. We're about to get into the nitty-gritty. Let's break down the 3 core principles that actually make zero trust a practical architectural reality and not just some abstract idea. And don't worry, it's not some crazy, complex framework. It all boils down to just these 3 fundamental ideas. Okay, first, we verify explicitly. That means we authenticate and authorize everyone and everything based on all the data we have, not just because it has a certain IP address. Second, we use least privilege access. This means you only get the keys you need for exactly as long as you need them. No more, no less. And third, and this one is so important, we assume breach. We design our systems with the assumption that attackers are already inside. This forces us to build in things like microsegmentation. Think of them like digital blast doors in a submarine. So if one compartment floods, it doesn't sink the whole ship.
So that's the theory. But what does this actually look like in the real world? Let's walk through a super common example that I'm sure you've all seen.
Okay, the scenario is this. A team has an application running in, say, Cloud A, and it needs to grab a secret, like a database password, from a vault in Cloud B. Now, the old way, you'd probably hardcode a credential right into the app's config file, and we all know that's a huge security no-no. But with Zero Trust, we can do this in a much, much smarter way. So check this out. Instead of a static password, the app in Cloud A asks a central trusted security guard, our identity provider, for a temporary hall pass. The security guard verifies the app's identity and issues a token that's only good for a few minutes. Then, the app takes that token over to the secrets manager in Cloud B. The secrets manager sees the token, trusts the security guard that issued it, and grants the app access. Simple, secure, and best of all, there are no long-lived passwords lying around waiting to be stolen. All right, now for the fun part. Let's pull all of this together into an actionable blueprint, a few key takeaways you can use for building out your own zero trust strategy. So here are the 5 big ones. First, the goal is to centralize identity, not your infrastructure. Let your teams build wherever they need to. Second, your applications and services, your workloads, need strong identities too. Treat them like first-class citizens, just like your human users. Third, automate everything you can when it comes to secrets and keys. Humans shouldn't be managing this stuff. Fourth, get rid of static, permanent credentials. Use short-lived, dynamic ones for absolutely everything. And finally, number 5,
You need one set of security rules that you apply consistently, everywhere, across all your clouds.
So I'll just leave you with this one question to think about. If your network perimeter was breached tomorrow, and let's just assume it will be, would your data still be safe? If the answer is no, or even a hesitant maybe, well, then it's probably time to start building your zero trust architecture.